Hello and welcome. So let's look at this problem, which is about projectile motion. Okay, let me explain. So we have been given a shell which is shot at an angle theta is equal to 80 degree with the initial velocity u is equal to 64 meter per second. Now what happens is this shot moves up to the highest point, and here it explodes into two pieces. The bigger piece, big M, falls down with zero velocity. Okay, it breaks down and falls down. A smaller piece moves like this. So in the part A, what we have been asked is how far does this big piece, which is of 9 kg, falls from the point of projection. Okay, so let's look at this thing. Suppose it falls at a location B. Okay, and this is basically corresponding to the maximum height of the projectile. So this will be half of the range. If the shot would not have been exploded, it would have fallen at a distance r. Okay, so this B is basically r by 2. Okay, so we can find it via two different ways. First, we can say the location of the 9 kg mass will be B from the origin and is equal to half of the range, or we can calculate the time to reach the maximum point and then calculate B. So let's do with the other approach. At the highest point, the velocity along y direction would be 0. We know the initial velocity of the projectile in y direction is uy plus ay into time of flight. Okay, this time of flight is to reach the maximum point. We know uy is equal to u sine theta, and we know ay, acceleration along y direction, is minus g. Okay, we have taken a sign convention. Anything that is in this direction is considered positive, right? And anything that is downwards, that is acceleration due to gravity, will be negative. So Vy is equal to u sine theta minus g time of flight, implies time of flight to reach the maximum point will be u sine theta by g. Okay, now let's calculate how much horizontal distance. Okay, the horizontal distance b is traveled with the velocity ux during the time of flight tf to reach the maximum point. We know ux is u cos theta. Time of flight is basically u sine theta upon g. So we have calculated b from two different ways. First, it's half of the range. Second, it is given by this formula. Now putting the values, what we can get is 64 meter per second u square 4.985 times cos theta 0.174 divided by 9.8 meter per second. Okay, solving this, what we will get is B will be 71.6 meter, right? So this is B and this is equal to half of the range if the shell would not have exploded. So we know the range is equal to 143.2 meter, and the point where the 9 kg mass falls at 71.6 meter from the origin, right? Okay, let's move on to the second part. This problem requires calculate the velocity of the 5 kg or the smaller piece right after the explosion. Okay, so we had a projectile which was sent with a velocity u at an angle theta with respect to horizontal. At the highest point, it split into two parts. One part fell down. The second one continued to move in this direction. Okay, as the force that caused explosion was internal, the external force is 0. So if we take the total mass n plus small m, big mass m is of the bigger projectile, which is 9 kg. The second piece, which is smaller one, small m, is 5 kg. Okay, so the total mass times the acceleration of the center of mass, okay, will be 0. So that means center of mass will travel with constant velocity. With constant velocity. Therefore, if you look at the center of mass right before the explosion, it was traveling, it had a mass this, it was traveling with a velocity u cos theta because the horizontal velocity is not affected. And then after the explosion, the small mass, suppose it travels with the velocity v that we have to calculate, plus the velocity of big mass, that is 0, because it moves with 0 horizontal velocity. So from this, what we can calculate is the velocity of the small piece of 5 kg. Okay, so we can see it will be m plus m divided by small m u cos theta. Okay, now let's plug in the values and get the answer. So velocity of the small mass, that is 5 kg, will be 9 plus 5 divided by 5 times u cos theta. U is 64 meter per second. Cos theta is 1 cos 80. From this, what we can get is basically the horizontal velocity of 5 kg mass. Okay, so that's the second part. So in the part C, they want to know at what horizontal distance in meter from the starting point does the 5 kg piece hit the ground? Now this is a conceptual and very nice question. Let's solve it. So we learned that the shell is fired. It explodes in two pieces at the highest point. The bigger piece falls down at the the range, okay, the smaller piece will continue. Okay, so if the shell would not have broken down, what would happen is basically it would fall at a point R, right? However, after the explosion, what happens is the smaller piece falls at a distance R by 2. I mean the 9 kg piece. And then another piece will continue its journey. It will fall a little bit far away. Okay. Suppose it falls at a distance x. So the 5 kg mass, it falls at a distance x. Okay. So in the end, what happens is, since the center of mass travels with a constant velocity, okay, so the location of the center of mass will not change. If there was no explosion, the center of mass of the m plus m system, that is big M, the 9 kg mass, small m, this 5 kg mass, would have been located at a point R from the origin. Now, this should be equal to the location of the big mass, which is at a point R by 2, and the location of smaller piece, which we don't know at x. So we have to find the value of x. We can clearly see we can write x as m by 2 plus m into range divided by small mass. Since there was explosion, the new pieces should fall in such a way that the center of mass remains at the same location. Okay, so that's why m plus m into r is equal to m into r by 2, the location of the bigger piece, plus m into x. So plugging in these values, what we can say, the location where the small piece falls is basically given by big M by 2 plus small m divided by small m times the range. We calculated the range to be 143.2, if you remember previously. So these parameters. So this basically turns out to be 19 by 10 times 143. So this range or the location of the small piece will be x equal to about 270 meters. Okay, so 5 kg mass falls at a distance 270 meters from origin. So thanks a lot. Have a great day.